Welcome back, everyone. Today we're taking a deep dive into the sometimes surprising world of large language models.
It's an area that's constantly evolving.
It really is, and we've got a fascinating paper to discuss today. It's called Thoughts Are All Over the Place, on the underthinking of o1-Like LLMs. And it really makes you think differently about how these models think.
Yeah, it seems like we often view LLMs, the AI that powers chatbots and assistants and all that, as these incredibly deep thinkers capable of, complex reasoning.
Hmm.
But this research suggests they might not always be living up to that expectation.
Right, they might be underthinking.
Yeah.
So let's break this down. What exactly are these o1-Like LLMs that we're talking about?
Well, they're a new generation of large language models, and they're inspired by OpenAI's O1 model. And some open source examples of these O1-like LLMs include, QWQ, DeepSeek, and Kimi.
Yeah.
And they're designed to really try to mimic human-like deep thinking, through reinforcement learning.
So unlike earlier chatbots that had pre-programmed responses,
Hmm.
these models actually learn through trial and error,
Yeah,
kind of similar to how humans do.
that's the key difference. They, try different approaches, learn from their mistakes, and really develop sophisticated reasoning abilities.
Mm-hmm.
And that enables them to, think strategically, explore multiple paths to a solution, and even reflect on their decisions.
That's impressive, but this research uncovered something kind of unexpected. Even with these advanced abilities, these o1-Like LLMs can exhibit this underthinking.
Right.
So what exactly did the researchers find?
Well, they observed these models frequently switching between reasoning paths without fully exploring any single one.
So it's almost like a chef constantly switching recipes mid-cook without ever actually finishing a dish.
Yeah,
You just end up with a jumble of half-baked ideas, but no complete result.
exactly. And to really test this, they used data sets with challenging math and science problems,
Hmm.
things like Math 500, GPQ-A, Diamond, and A.
Okay, so real complex problem-solving scenarios.
Yeah. And what they found wasn't just about wrong answers, but a lack of depth in exploring these potentially correct lines of reasoning.
Hmm. So they might have a promising approach, but just abandon it too quickly.
Correct. And one finding that really highlights this is that these O1-like LLMs use 225% more tokens. Tokens are like the building blocks of language for an LLM, so think pieces of words or code.
Right.
They use 225% more tokens in incorrect answers compared to correct ones.
Wow.
So there's a lot of inefficient thinking going on there.
Yeah, it seems like it's stemming from this prematurely switching between thoughts. Can you give us like a specific example of this underthinking in action?
Yeah, figure 2 of the paper shows a model initially making a good observation about a problem that involved ellipses. It recognized the key geometric shapes involved,
Uh-huh.
but instead of exploring that path further, it jumps to other strategies like algebraic manipulation or optimization techniques and ultimately just leads to an unsupported guessed answer.
So it seems like the LLM was capable of solving the problem, but just didn't give itself enough time to really think it through.
Right. It's like it had the aha moment, but didn't follow through.
Didn't follow through.
Yeah.
And to measure this behavior, the researchers developed a new metric called the underthinking metric.
Mm-hmm.
So how do you measure something as complex as underthinking?
Right, it's a good question. The underthinking metric essentially looks at the efficiency of token usage when an LLM produces an incorrect answer.
Okay.
And it calculates the proportion of tokens used before abandoning that first correct thought.
I see.
So a lower score indicates better efficiency.
So it's like measuring how long the LLM can stay focused on a potentially good idea before it gets distracted by other possibilities.
Exactly.
Okay, this provides a way to actually quantify underthinking and compare different LLMs.
Right, and it also raises the question of can we reduce this underthinking? Can we help these LLMs become more efficient thinkers? And the researchers believe we can, and they propose a technique called the thought switching penalty, or TIP.
Interesting.
Yeah.
This thought switching penalty, this tip. It sounds promising. So how does it actually work?
Well, you can think of it as a gentle nudge during the LLM's thinking process. Imagine you're trying to solve a puzzle and you're constantly getting distracted by other pieces. Tip is like a little nudge that helps you focus on the piece you're currently working with. So it makes the model slightly less likely to jump to a new thought without completely restricting its exploration.
So it's not forcing the LLM down a specific path, but it's encouraging deeper thinking before switching gears. Did the researchers find that this technique was actually effective? Did it actually improve the LLM's performance?
Yeah, they tested it out on those same challenging data sets, the Math 500 hard, the GPQA Diamond and the AM 2024, and their results showed that using TIP led to improved accuracy on these problem sets.
Interesting.
So the LLMs were more likely to find the right answer when they were encouraged to, think more deeply about their initial ideas.
That makes sense. Were there any downsides to using this TIPI? Did it make the process slower or less efficient in any way?
Well, one important point is that these improvements were achieved without retraining the entire LLM,
Oh, okay.
which, retraining a large language model is a very time-consuming and resource-intensive process.
Absolutely.
They simply adjusted the decoding process, the way the LLM generates its responses.
So that's a significant advantage from a practical standpoint. That means we can potentially improve the reasoning capabilities of these LLMs without having to start from scratch.
Right.
Did the researchers apply this underthinking metric to different LLMs to see if some were more prone to this behavior than others?
Yeah, they focused on three specific O1 like LLMs, QWQ 32B preview, DeepSeek R1 preview, and DeepSeek R1671B, which represent a range of, complexity and capabilities.
And did they find any correlation between the size or the complexity of the model and its tendency to underthink?
Well, the relationship wasn't always straightforward on Math 500 Hard and GPQA Diamond. The most capable model, DeepSeek R1671B, actually had higher underthinking scores despite its higher accuracy.
That's kind of surprising. Yeah. You'd think a more powerful model would be less prone to those sorts of shortcuts.
Yeah, you would think so. The researchers suggest that this larger model might overcompensate when faced with uncertainty. It explores many incorrect paths.
Hmm. It's like having too many tabs open in your brain.
Yeah, it can lead to distractions and inefficiency.
But on the AME 2024 dataset, DeepSeek R1671B achieved both higher accuracy and a lower underthinking score.
Right.
So it seems like the relationship between model size accuracy and underthinking is pretty complex and likely influenced by the specific demands of the task at hand.
Yeah, it really highlights the importance of going beyond just simple accuracy when we're evaluating LLMs. We need to consider how they think, how efficiently they use their resources, and how prone they are to this underthinking phenomenon.
And the underthinking metric gives us a valuable tool for doing just that.
Yeah, it allows us to assess these less obvious aspects of LLM performance and potentially guide the development of more effective training techniques.
Right. So by understanding and addressing this underthinking, we can move towards building truly intelligent systems that are capable of tackling these complex challenges with more human-like reasoning.
Exactly.
It really makes you think differently about AI and its progress, doesn't it?
It does. It reminds us that we're still in the early stages of really understanding these systems.
And,
There's more to AI than just getting the right answer. It's
right.
about the thought process, the efficiency, the depth of understanding. All of those things matter.
And as we develop increasingly sophisticated LLMs, understanding these nuances becomes even more critical.
Yeah, this idea of underthinking, it's something that everyone should be aware of. Not just people who work directly with AI, because these systems are becoming more and more integrated into our everyday lives.
That's true. And as we rely on them more, we have to understand their limitations and how their thinking might differ from our own.
This research gives us a glimpse into those differences. It equips us with the knowledge to really evaluate the outputs of these systems critically.
It encourages us to ask not just what, but how.
Right.
How did the AI reach this conclusion? Is it based on a true understanding of the problem, or is there evidence of this underthinking going on?
These are crucial questions we should all be asking as we navigate this increasingly AI-driven world. So in this deep dive, we've explored the complexities of AI and how these systems sometimes fall short of true deep thinking.
We've seen that even the most advanced AI can get sidetracked and lose focus, just like our chef with too many recipes.
Yeah.
It's a reminder that building truly intelligent systems requires more than just increasing their size or complexity.
We need to understand how they think, how to measure their efficiency, and how to encourage deeper, more focused reasoning.
And this research offers valuable insights into those areas, paving the way for the development of more effective training techniques and ultimately more reliable and trustworthy AI systems. Well, thanks for joining us on this deep dive into the world of underthinking in large language models.